Okay, let's move to the second question. It's about an element. It's Y. So let's consider YF4 plus ion. So central atom is Y. Then there are 4 fluorine atoms, and the shape of this ion is tetrahedral according to the question. So we can draw the shape like this. So where should I mark the positive charge? We know that when there is a positive charge, that charge must be on the least electronegative atom. So out of Y and F, which element is the least electronegative element? You may think that as Y is unknown, we cannot deduce that, but is it not correct? What is the reason? We know that the most electronegative element is fluorine. Therefore, definitely, whatever the element Y, the electronegativity of Y is less than fluorine. That means it is the most electropositive or least electronegative atom in this ion. So positive charge should be on Y atom. So how many valence electrons are there when we consider the Y atom? 1, 2, 3, 4. As there are 4 bonds, there are 4 valence electrons. So that is unipositive ion of Y. Then how many valence electrons are there in a Y atom? There must be 5 valence electrons. So what is the group of Y? Group of Y should be 50. Sulfur group 16 element, nitrogen group 15 element, boron group 13 element, phosphorus a group 15 element, chlorine a group 17 element. So answer should be either nitrogen or phosphorus. Then we can move to the next ion. Let's consider YF6 minus ion. So the shape is octahedral. So there is a negative charge. So negative charge should be on one of the fluorine atoms. So it forms a dative bond. So when we consider Y atom, there must be 1, 2, 3, 4, 5 valence electrons. So it concludes that Y belongs to group 50. And when we consider this ion, there are altogether 12 valence electrons around Y. So when we consider nitrogen, the maximum number of valence electrons around a nitrogen atom will be 8, because valence shell is second principal energy level. So 2s and 2p, therefore maximum hybridization can be sp3. Therefore maximum valence electrons around a nitrogen atom is 8. But when we consider phosphorus, valence shell is third principal energy level, so it can reach sp3d2 hybridization, and there can be 12 valence electrons around the phosphorus atom when the hybridization is sp3d2. Therefore it's clear that Y should be phosphorus. So which means the correct answer for this question is fourth one. So you may draw the shape of YF4 minus ion. So central atom is Y, then the shape is seesaw. Then one fluorine atom is negative. Then to obtain the seesaw shape, there must be a lone pair. As there are 10 valence electrons around the Y atom, Y cannot be nitrogen, Y must be phosphorus. So that's how you should get the answer to this question. Most common mistake when writing answers to this question is some students mark the correct answer as the second one, selecting nitrogen as the element Y, but it is incorrect. Even though it is in group 15, it cannot form sp3d2 or sp3d hybridizations. Therefore there cannot be valence electrons more than 8 around nitrogen atom.